So, welcome to my presentation. So today I will also look a little bit back on where these AI algorithms come from, and I had the opportunity to work at Carnegie Mellon University when, let's say, Jeff Hinton was also there and new things were developed. So let us look back and also figure out what is still important today. So AI can, in principle, be applied in two ways. First of all, it can be used for functionality of the car, and then the AI can sit in the car or can be provided by the backend. Second application is, and I will talk about that today, AI in automotive processes. And the opportunity is, of course, reduced effort and immensely speed up of development. And honestly, we need a huge step in this, and not a small one, and also fill the resource gaps, because sometimes it's hard to find the right capabilities. So the challenge here is how to integrate that really in our processes, because we have developed a whole process system that works in conjunction. So, and I will focus on this point today. So if you look at our processes and where we can apply this GenAI, we have to consider two things. First of all, data, and secondly, how many times do we really need this? If you look at requirements, requirements are touched many, many times in a project. We have 10,000 of requirements. We touch them several times, so that's a real frequent application. If you look at testing, the same. 10,000 of testing cases, we touch them several times, so many, many applications, lots of data. And the same for code generation. Many, many code lines written, touched many, many times, so we have lots of data, we have lots of applications. And this is important because we need them for the adaptation of the algorithms. In the preparation of this presentation, I tried to figure out how will it look like after the break. And so I made a little video with GenAI. And I typed in big audience of automotive engineers in a large hall, listen to speaker after lunch. And we get this result here. And it's a nice video. And I thought it's great example of what GenAI can, with very simple prompt, generate today. But I thought it was a little bit less attenuation of the audience and also less attenuation of the speaker. So I typed in, I want a blonde male speaker after that, and I want an exciting blonde speaker. So I got this one here, and I think it has a little bit interaction with the audience, and it tells you, okay, this is really simple typing in of simple prompts. And the result is already something that you can look at, it's pleasing. And if you would like to generate that with computer graphics, that would be immense effort behind it. So there is a great benefit from GenAI, so it's something that we should use. So, but then the problem is, how do we integrate the scenes together? If you look at the results, they're not quite the same. Both are pleasing, but they're not quite the same. So how do we match them together? Because in our application of GenAI in automotive, it's not the single line of code, it's the whole software that counts. Now we need to integrate the software elements together to get the working software. So where do I come from? As said before, I was at Carnegie Mellon at the end of the 80s, where this kind of book was published. And in this book, there is this paper of this gentleman, Geoffrey Hinton, where he got, basically, he was nominated, or he was awarded the Nobel Prize recently. And at the time, we built a speech recognition system and a speech translation system afterwards. And 30 years ago, in 1994, we were able to translate speech from one end of the Atlantic to the other. Today, it looks like normal Teams meeting, but at that time, it was quite fancy. In 1994, people were getting their first email account, and at that time, we could translate speech and talk to each other in different languages. So this technology, you know, by now, it's in half of the cars, as said before, and it was translated to small mobile phones and then acquired by Facebook in 2013. But from that time at Carnegie Mellon, I got the spirit of what AI is, and I would like to bring to your attention two selected characteristics that are important for AI also today. So first of is, and this is also what Jeff Hinton was always interested in, how do people learn? And people learn, you can observe when people are learning how to add numbers. You go to a schoolroom, you look how the students learn how to add numbers, and there's a teacher. The teacher presents a number of cases, very simple cases, and explains how these numbers are added. And then, at the end of the training session, they write an exam. And all teachers do the same for this exam. They check for different things. They have different types of questions for the exam to figure out what has been really learned and what has not been learned. So the first type of question is for memorization. Check if at least the students have memorized the right answer. You can, of course, only use that for the cases that are the same as in the training. So this is the first level. It's memorization. Then there's a second level. It's small modifications of the training examples. It means some minor modifications, and the students have learned some concept of what is going on and how to add numbers. So we look for a generalization capability for small modifications. And then there usually is a set of questions that asks for more modification. You check if it's robusted against expected real-world examples. And nowadays, in our world of automotive, we have SOTIF. And in SOTIF, we explicitly look for unknown cases. These are cases that at the point of time of training are not even known to the trainer. And here, giving some examples here. So this is the psychological background of what these neural networks learn. And what we really are looking for is the generalization capability. We want to go beyond memorization. And that's the key feature that elevates it beyond table lookup, semantic search, and so on. Second thing I brought to you, on the left-hand side, you see how these systems for speech and language modeling evolved over time. So 87, they have been quite simple, small, restricted in language for 6,000 parameters. In 2023, this ChatGPT 4.0 is 170 trillion parameters. So it has gone a long way over 4 decades from a restricted language to a real large language. We are talking about large language models today. However, this comes at a certain cost. So if you look at the 2022 numbers, OpenAI expenses for that is $550 million. And a little bit surprising to the automotive industry, 76% is on computing and data. I think in automotive, it's the other way around. And now, if you look back, they are able to amortize that by a large number of use cases. So this is what I said in the beginning. If you want to apply GenAI to your processes, look for processes that have a large number of applications, thousands of requirements to be processed every project, 10,000 of test cases provided every release for every process. So that's where you can amortize the investment into GenAI. So now let's go back to code generation today. So in 2021, OpenAI published the paper that started it all. They said, okay, with this proof-shop prompting, we can do excellent code generation. So you put in a prompt, a natural language statement, and you actually get really good code out of it. And So now the question is, how can this be integrated into automotive? So here you see our well-known development processes. So we start on the system level, then we go to software level, and finally we do the code generation. So now the question is, how can we bring this in? Because if we really face it, the ability of a software engineer to develop the code exactly to the requirements and exactly to the software architecture, that is what distinguishes the experienced software engineer from the beginner. People coming from the university, they know usually how to write this one line. But their gaining experience is really to match it to the rest of the software system. So now, let's face it, how do we do it? If you look at typical prompts, there is no information about software architecture in the prompt. And so how can we get the software requirements in it? How can we get the software architecture design in it? How can we do that? And so, because software development is much more than just writing one line of code. It's more. It's an integrated process. You bring things together. So I've now prepared several options to discuss these ways how to can bring it in. So either we enhance the GenAI or change our development philosophy. So let's go through the options one after the other. Option one, so we say, okay, the opportunities are so great. So let's forget about our development philosophy completely and just use GenAI to do it. So then that would mean we just wipe out the left side of these processes here. We just put in a prompt, we generate the code, and then we start integrating. Honestly, this reminds me of software development 20, 25 years ago. You had a complete week of software integration, and the integrator was sitting on the phone all the time, trying to put the puzzle pieces together. That by no means fits to the complexity of our software today. We cannot do that. So it's not clear how we finally put together the system. It's not clear how we can get the software integrated. So how to put all the puzzle pieces together, not acceptable today. So let's forget about this option. Next option, option two, adapt requirements engineering and architecture design to better fit to GenAI, to this prompt inputs. So let's have a look at that. So requirements engineering is quite a mature discipline. So you have several levels of requirements. So on the first level, you usually have natural language statements, but they're typically done using a template. When, who, must, do what. It's a typical template, and if you use the template, you are, let's say, creating better natural language requirements. Then we typically have a second level. We have a so-called semi-formal requirements that add inputs, outputs, sequence information to that. And then we have a next level where we have diagrams, activity diagrams, sequence diagrams. So this is requirements engineering today, a mature discipline. So how does it compare to prompt engineering? Prompt engineering is now a quickly emerging field because people figure out if you just type in a prompt, we may not get what we want. So people are writing lots of papers about prompt engineering. And it starts on level one, zero-shot prompting. So you have a natural language statement, and by the large language model, GenAI is able to understand that. So however, we figure out there's a lot to be improved. You don't know what you really get. Sometimes you're just trying around, and usually prompts get longer and longer and longer. You put more details in and hope that result gets better. And then we have a second level, the so-called few-shot prompting. prompting, that means you add examples of what you expect. And also that improves the result. And for code generation, you also have this chain of thought prompting and structured chain of thought prompting. You put more and more structured information in, and you get better results as the output of the GenAI. So what I see here, we have a very similar approaches now. We have requirements engineering, we have prompt engineering, and it's working and it's evolving in a similar way. So that is why I come to the conclusion, yes, we can adapt to that. It's already moving in a similar direction as our known requirements engineering, so that's fine with us. So, and if there is something to be sorted out, I think we can deal with that. But now let's have a look at the software architecture. And the software architecture is really something that needs consideration. So if you look at the original paper of OpenAI, how they started it all, they described of what the databasis of this is. The databasis is taken from public directories of openly available software, and it's in the end, it's about 160 gigabytes, so the amount should not be surprising, but there is no information about software architecture in it completely. So the GenAI is not listening to something like software architecture. And you can imagine the underlying software architectures are diverse. It's a whole conglomerate of software architectures that you find by accident in these public directories. So we don't know what the underlying software architectures is. We just know it's a variety. So my conclusion is here, it's based on this vast conglomerate of architectures, and it does not listen to a channel, to an ear. Listen, I want this architecture or I want the other architecture. It's just taking something out of it. It's not really understanding what the software architecture is. So, and I come to the conclusion, so this is not really adaptable to us. So we need an architecture, we need to understand, let's say, where the controller is, we need to understand where the sensor is connected, we need to understand where we calculate the current and so on. So I come to the conclusion, if you look at option 2, yes, for requirements engineering, we can adapt to that, but there is a no for software architecture. The way the current GenAI is, there's no way to talk to it about software architecture design. So let's come to the next option, enhance GenAI by including requirements and architecture via something that is called a plugin. A plugin is something like that. You connect a third application to the GenAI large language model about, let's say, travel flight information, the weather. The restaurant is closed today, or the restaurant opens at 7 p.m. or something like that. This is typically information that is connected to GenAI by so-called plugins. And this is an interface that needs to be provided by the originator of the GenAI. So if we want to use this option, we have to closely work together with the originators. We have to tell them, look, we want an interface to software architecture. Please build this interface. And honestly, I don't know what the output of this will be, because this interface is not so well prepared to really provide this generalization. This is why I come to the next option, include requirements and architecture in the training. And we have the situation here. We have code only. On the left side, we see the situation we have. We have training examples that include code only. Now, if we would like to also include requirements, the architecture element and the code together as a triple by traceability. You have said a training pattern is code plus architecture plus requirement. Then we would need much more than the 160 gigabyte of data. And I really suspect that this data is not available publicly, because Yeah, in all the public repositories, there is not something like that. Traceability to requirements, traceability to architecture elements you don't find in public repositories. So we cannot find really this data. So this is why I come to the proposal and my preferred option, train a specific auto AI, where we say, okay, we have our automotive domain, and in our automotive domain, we have, let's say, one standard architecture. One standard architecture where we can collect in our industry lots of data points consisting of code, requirement, and the associated architecture element. And if we use that to train a generative AI language model, then we can succeed in bringing in requirements and architecture information into this Gen AI. So we learn from many examples how functions are coded in an automotive standard architecture. So this, by the way, is what humans are doing that are working in our companies. Yeah? They learn over time how usually software is written in our industry. And that they read the architecture, they read the requirements, and then they start coding. So the proposal is here in order to bring the needed amount and manpower and resources together to define, let's say, a standardized automotive architecture, have a conglomerate, have a consortium of creation partners that put in data and expertise, and have, let's say, contribution partners that put in data points, and by that we get an asset pool, we get a data pool, we get a resource pool. And instead of all of them working independently and training little Gen AI, spend a combined effort to create an auto AI, something that has learned to code in our domain, in our automotive standardized architecture. So to summarize my presentation, I'm convinced, and I think this is common by now, Gen AI will become a game changer for our industry. So my recommendation is, if you want to apply that in your development, use it for where the frequency of applications is. That's requirements, that's testing, and that's coding. And if we want to really use that and create code, I recommend to go for this auto AI joint collaboration to develop something that writes code in the context of a standardized architecture. And the specific challenge of how to get a software architectural design, I currently see no other means to provide it besides the proposal here to go for this way. I mean, we have really done great things with AUTOSAR for the automotive industry. That was a standardization approach. Here we have the same approach, a similar thing, to say we bundle our resources, we have a standard, we build a Gen AI for it, and then we can really achieve big improvements. Thank you very much for your attention, and now I'm looking forward to your questions. Thank you.
Thank you very much. Great presentation, because somehow it addressed all the topics that as a high-level manager you would think about. Why don't you do this? Why don't you do that? And you also somehow, you took away some of the prejudices. Why can't you just have GenAI create code? So great presentation. There's also a few questions. I would like to start with one, because you're preferring this standard architecture model. Mm-hmm. And as you know, how easy it is to standardize things across the industry. It mostly takes hours or maybe days. It takes a long time. And also the architectures are very different. So my question would be, how would you come to that reference architecture, or could it even be generated automatically?
Okay, very good question. Yeah, as we have seen with the numbers from the company OpenAI, I mean, the investment in developing a large language model is big. But as OpenAI have shown, it can be amortized. They have, let's say, a number of users that pay for it. So I don't say that the approach that I'm proposing to develop something for the automotive standard architecture is simple. AutoSAR was also not simple to define and to create, but in the end, it helped us quite a lot. I think it's a significant investment, so this is why I'm also bringing it to the audience, because it's not a single company that says, yes, we do it. It will need a certain consideration and also a certain vision to bring this forward. So it's not easy, it's not in a couple of hours, it's not a couple of days, it will be a huge initiative if you do it, but I think if we really go with this trend, GenAI, and using it, and I think we can need all the improvement and efficiency that we can get.
There's quite a few questions on exactly that effort to come to such a joint approach. One is that if automotive OSS initiatives will provide consistent requirements as a prerequisite, architectures and codeways, how much input, and I would add effort, would be required to train and test?
Can you say the last word?
How much input would be required to train and test?
Okay. I think there's one thing to get the resources together. Sure, we need to collect, let's say, 50 gigabytes of data to give a number, maybe 10 gigabytes is okay, or 20, 50. It will be a more specific language model than before, but it will need, let's say, a serious hardware to run this, to train such a model. I mean, we have you have seen the numbers, what OpenAI is spending. So it's really bundling the resources of our industry, and currently I cannot calculate it precisely. I mean, we would need to dive into that and first start to collect the data points. I mean, this is the basis. Yeah. So as we have seen, things can start small. They need time to mature, and then in the end you get great things. Yeah. So it took Jeff Hinton 40 years to get the Nobel Prize, but in between many things happened.
I don't know whether they have another 40 years, but
no, we don't have. We must start as soon as possible.
Yeah. Also to your approach, again, a question about the effort and at the reward that we have. There's one question: what would you guess as % of time and efforts reduction applying at scale GenAI along the V cycle as you propose?
So if we think of the left side of the V cycle, including code generation, so for requirements analysis, software architecture, design, and coding, I mean, we spent, to my estimation, about 20–30%, no, 40% of the whole software development for that. And there we have this complete 40%, yeah, roughly. I mean, this is just an estimation. I would say 50% is software testing, then 10% running CI/CD, but for 40% is possible, I think.
That's wonderful. I mean, that's a perspective that we can.
But it needs a serious input. Look at the numbers: 550 million spending of OpenAI just in 1 year, and it's a collaborative effort.
Here's a good cultural question, talking about how can we make it. And we have a lot of vehicle lines, we have a lot of companies, but also within companies, a lot of units that do every part of the V, some do testing, some do this. So great many units that are involved. So the question is, how are partners in the AutoAI approach supposed to be aligned to collaborate in the context of different organizational cultures, architectures, and know-how?
Sure. I mean, this certainly needs trust. I mean, if we look back to AutoSAR, I mean, previous to AutoSAR, everybody thought, yeah, we invent this kind of architecture by ourselves, and then it was standardized, and in the end, we figured out it was improving the situation, it was enabling, let's say, the complexity of software that we see now, and so it also helps to bring the cultures and the companies together and make one unified approach. I mean, we are challenged by that. If we stay the way we develop software, the world outside will certainly disconnect us.
Well, you're available for more questions, I think, later on the table. So I would like to thank you very much on behalf of the audience for your presentation and the questions you answered.
Thank you.